Good morning, everybody. This is the physics exam review worksheet for semester 3, grade 7 at the International School of Innovation. Let's start with question number 1. Convert the following. We have 100 Pascal equal how much in kilopascal, 2 atmosphere equal how much in Pascal, and 1 atmosphere equal how much in centimeter Hg. Okay, let's start with Ali. Ali Rai, 100 Pascal equal how much in kilopascal?
0.1 kilopascal.
0.1 is divided by 1000, so it will be 0.1 kilopascal. Okay, since 1 kilopascal equal how much? Equal 1000 pascal. Okay, the SI unit of pressure is the pascal. Okay, 2 atmosphere. Hamad Hassan, 2 atmosphere equal how much in pascal?
100,000.
Okay, since 1 atmosphere it's equal to 100,000 pascal, so 2 atmosphere is equal to 200,000 pascal. Moving to 3, 1 atmosphere Abbas equal how much in centimeter Hg? 76 centimeter Hg. For example, if I told you 2 atmosphere equal how much in centimeter Hg? Yes, Lynn. 2 atmosphere equal how much in centimeter Hg?
100
times 2.
Yes.
Okay, you have to multiply by 2. That's it.
152.
Okay, it will be 152. Moving to question number 2. We have a container full of water and we have an empty glass bottle. A student inserts the bottle in the container as in the adjacent figure. Part 1. Water doesn't enter in the bottle, meaning that water doesn't enter into the bottle. Justify. Why? Yes, Neil.
Since the bottle contains air which exerts a pressure preventing the water from entering.
Okay, so air exerts pressure that prevent the water from entering into the bottle. So, since the bottle contains air, this air exerts a pressure, so prevent the water from entering into the bottle. Moving to part 2. The student inclined the bottle. Inclined. Okay, make it like this and like this and shown in the figure. Water enters into the bottle. Explain why. Yes, Tala.
Bubbles of the air come out of the bottle and
Yes.
water fills the bottle.
Okay, excellent. So bubbles of air, they goes out from the bottle and so water fills this bottle. 3. Yes, Lua. What will you observe in the container? What you are going to see in the container?
We will observe bubbles of
Yes.
air in the container.
What does this indicate? This indicates the existence of air. So, student incline the bottle, water enters into this bottle. Explanation: bubbles of air come out of the bottle, so the water can fill this bottle. What will you observe in the container? We will observe bubbles of air in the container. What does this indicate? This indicates the existence of air. Question number 3. After filling a tube with water, we seal one of its open ends with our finger and we reverse it. We seal it and we cover it with our finger and we reverse it. The water contained in the tube doesn't flow out of the tube. Explain. Yes, Linda.
The atmospheric pressure that's exerted is greater than the pressure exerted by water in the tube.
Okay.
So the water in the tube doesn't flow out of the
Excellent. So the atmospheric pressure is related to atmospheric pressure. So the atmospheric pressure which is exerted is greater than the pressure exerted by water into the tube. So the water in the tube doesn't flow out of this tube. Thank you. Moving to question number 4. The experiments below are done to find the density of silver. First experiment. We put small piece on an instrument X. This instrument X is used to measure the mass, as shown in the figure below. Ala, give the name of this instrument X. Two-arm balance. For example, you have other balance is called digital balance. Give the mass or find the mass of silver. It's present in the figure. Yes, Joel. The mass of silver.
40 grams.
Yes, it's 40 grams plus 65, so it will be 105 grams. That's it. Convert it to SI unit. Yes? Divided by 1000. SI unit of mass is what? Kilogram. Okay, you have to know that the SI unit of the mass is kilogram. SI unit of volume is the meter cube. Okay? So in order to convert from gram to kilogram, we have to divide by 1000. So 105 gram divided by 1000. It will be 1, 2, 3. This is the point, and we put a 0. 0.105 what? Kilograms. That's it. Okay? So the name of the instrument X is called two-arm balance. Mass of silver, it's 40 plus 65, it will be 105 grams. Converted into SI unit, it's 105 divided by 1000, so it will be 0.105 kilograms. Second experiment, we need to find the volume of the same piece of silver used above. We use the same piece of silver. So we did the following experiment. We have this graduated cylinder. This graduated cylinder includes only water. So V1, it will be 40 milliliter. Why? When we insert a piece of silver in the graduated cylinder, the level increases to be 50 milliliter. First, it was 40. When we insert the silver, it increases to reach 50. Part 1. Calculate the volume of silver converted into SI unit, and then we have to calculate the density of silver into SI unit. Volume of silver, it's what? Yes, Abbas, volume of silver. How can we calculate the volume of silver? We have to subtract or we have to add? Yes? V2 minus V1, it will be what? 50 milliliter minus 40 milliliter, it will be 10 milliliter, which is the same as 10 centimeter cube. Okay, we have to convert it into SI unit. What is the SI unit of volume, Abbas? SI unit of volume? Meter cube. So, as we know, the conversions, we have meter cube. That's a meter cube, which is the same as the liter, and we have milliliter or centimeter cube, which is the same as milliliter. Okay, we have to convert from centimeter cube to decimeter cube. What we have to do? Yes, Lynn? Divided by 10 to the power 6. So it will be what? 10 divided by 10 to the power 6. Okay, it's 10 divided by 10 to the power 6. How many positions should we move? 6. Okay, it's 1, 2, 3, 4, 5. This is the 6. 0, 0, 0, 0, 0. Okay, and we eliminate here the 0. So it will be 0 0.00001. 0.00001. What is the unit? Meter cube. You don't have to forget the unit. Okay, unit is important. Calculate the density of silver. How can we calculate the density? What is the property of density? Yes, Tala. Density is equal to what? Ratio of? Okay, so rho is equal to the mass over volume. Mass is equal how much?
0.105 kilograms.
Okay.
Over 0.00001
0.00001 meter cube. Pay attention here. We have two units of density. Okay, we have the SI unit, which is kilogram per meter cube. Also, we have other unit which is used gram per centimeter cube. Pay attention. If you use the mass in kilogram, so the volume should be in meter cube. And if we use the mass in gram, so the volume should be in centimeter cube. Okay, SI unit is kilogram per meter cube, so we use kilogram per meter cube. So 0.105 divided by 0.00001 meter cube. So the density, it will be what? Yes, Dana?
10,500 kilogram per meter cube.
10,500 kilogram per meter cube. Okay. Muhammad Hassan, what is the density of water in It's SI unit in kilogram per meter cube. What is the density? 1000 kilogram per meter cube. In gram per centimeter cube? Yes. It's in gram per centimeter cube. It's 1 gram per centimeter cube. Okay? Calculate the relative density. What's the property? Or what's the relative density? Yes, a lot. Relative density. What's the property of relative density? The density of the substance over the density of water. These two densities should be expressed in the same unit. For example, if I use the density in kilogram per meter cube, I have to use the density of water in kilogram per meter cube. If I use it in gram per centimeter cube, so I have to use the density of water in gram per centimeter cube. So calculate the volume of silver is 10 milliliter, sand volume to be converted into SI units divided by 1 million divided by 10 to the power 6, it will be 0.00001 meter cube. Density, which is rho, it's equal to the mass over the volume, equals 0.105 watt kilograms divided by 0.00001 meter cube, so it will be kilogram per meter cube. Okay, moving to the relative density. What is the relative density? It's density of the substance over density of water. 10,500 kilogram per meter cube divided by density of water 1,000 kilogram per meter cube, so it will be 10.5. Pay attention here. Relative density should be without a unit. Okay? Have no unit. 10.5 alone without a unit. And in order to be without a unit, these two densities, density of substance and density of water, should be expressed in the same unit in order to be without a unit. Okay? You have to pay attention in your exam for mass, the units of mass, how we convert the units of mass, the SI unit of mass, volume, SI unit of volume, and how we convert volume. We have to know density, the property of density to the mass, ratio of the mass over the volume. We have to know that relative density is the density of the substance over density of water. They should be expressed in the same unit. They don't have, relative density has no unit. You have to know the pressure, atmospheric pressure. It's measured using what? Atmospheric pressure? Barometer. Like pressure of confined gas is measured using metallic manometer or not? Not metallic, manometer. Yes, it's manometer, not metallic. Not say metallic. And moving to 1 atmosphere equal how much in bar? You have to know it. 1 atmosphere equal 1.013 bar. It's equal how much in Pascal? Equal 100,000 Pascal. Equal how much in centimeter of mercury? It's equal 76 centimeter Hg. You have to know all these samples. You have to know the definitions, study definitions. For example, I may ask you, what is the definition of density? What's the definition of relative density? What is the atmospheric pressure? It's the pressure exerted by air. Okay, you have to know these definitions. Okay, thank you.